If you want to understand why space travel is expensive, you have to start by setting aside one of the strangest habits of modern life. People will look at a rocket and compare it mentally to an airplane ticket. They think, well, both are forms of transportation. Both move people or cargo from one place to another. So why should one be merely annoying to purchase while the other burns through fortunes like a duke with a torch in a hay barn? Because space is not far away in the way Chicago is far away. Space is hostile in the way the bottom of the ocean is hostile, except the ocean at least has the courtesy to provide pressure in all directions. Space gives you vacuum, radiation, temperature extremes, orbital mechanics, and a level of punishment that would make a submarine captain kiss the deck and ask for a gentler assignment. That is the first problem. Space travel is not expensive because people in the industry are stupid, lazy, or malicious. It is expensive because the task itself is obscene. You are trying to hurl fragile life support systems, delicate electronics, tons of fuel, and often human beings, off a planet that is actively holding on to them with gravity. Earth is not a launch pad. Earth is a jailer, and gravity is a very good jailer. People speak casually about going to space as if it were a long elevator ride. But rockets do not float upward because they have good intentions. They fight their way out by throwing mass downward at astonishing speed. That takes enormous energy. It takes fuel in grotesque quantities. It takes structures that are light enough to fly, but strong enough to survive violence. And that tension, light but strong, is the sort of engineering requirement that causes wallets to whimper. Every kilogram matters. A spoon matters. A bolt matters. A seat matters. Add a kilogram to the payload, and you may need several more kilograms of propellant to move it. But that extra propellant itself has mass, which may require more structure, which may require still more propellant. This is the tyranny of the rocket equation, one of the great killjoys of human ambition. It has ruined many beautiful dreams with the cold patience of a tax collector. That is why rockets look the way they do. They are mostly propellant tanks with a small amount of useful stuff perched on top like a crown on a very nervous scarecrow. Space travel is expensive because the machine has to carry the fuel, to carry the fuel, to carry the fuel, to carry the payload. It is a kind of mathematical cannibalism. And fuel alone is not the whole story. The rocket has to survive launch. That sounds obvious until you think about what launch actually is. Launch is a controlled explosion so large and so deliberate that we have trained ourselves to call it transportation. The vehicle shakes, it flexes, it roars. It experiences intense aerodynamic forces as it punches through the atmosphere. Temperatures swing. Vibrations rattle through every wire and fitting. If you are launching a satellite, that satellite must be built to survive this assault before it ever begins doing its actual job. So now the satellite costs more. And then people ask why the launch costs more. Because the satellite is delicate and expensive and the rocket carrying it cannot be allowed to fail. Or rather, it can fail. But if it does, it will transform years of work and hundreds of millions of dollars into an educational fireball. Engineers, for reasons that remain mysterious, dislike educational fireballs. So they design for reliability. They test, they inspect, they document, they review, they simulate, they certify, they test again. This is where many outsiders get bored because they want the answer to be some sleek, cinematic phrase. They want the answer to be advanced technology or high-performance systems. That sounds nice. It also explains nothing. Space travel is expensive because failure is catastrophic and success requires a fanatical intolerance for small mistakes. A bad weld in a garden shed gives you a crooked shelf. A bad weld in a launch vehicle may produce a crater and a congressional hearing. That changes the culture. It changes the paperwork too, which is less glamorous but no less real. If you are launching anything serious, you are not simply building a machine. You are building a machine inside a fortress of process. Quality assurance, mission assurance, supplier oversight, regulatory compliance, range coordination, software validation, flight readiness reviews. Even the acronyms have acronyms. Bureaucracy in space is not always pointless. Much of it exists because the hardware punishes sloppiness with biblical enthusiasm. Then there is the simple fact that space systems are often built in low quantities. This matters more than people realize. A Honda Civic is cheap, relatively speaking, because Honda builds mountains of them. The tooling is spread across vast production runs. The suppliers are mature, the workers are practiced. The design evolves over time. Every mistake can be amortized, corrected, absorbed into scale. Spacecraft do not usually enjoy that luxury. Many are bespoke machines, tailored for a specific mission, a specific orbit, a specific customer. When you build 5 of something, or 3, or 1, you do not get the full blessing of mass production. You get craftsmanship at industrial scale, which is a very elegant way of saying expensive. When you build 5 of something, or 3, or 1, you do not get the full blessing of mass production. You get craftsmanship at industrial scale, which is a very elegant way of saying expensive. Even rockets that launch more often than they used to are still nothing like automobiles or consumer electronics. An airplane manufacturer may produce hundreds of aircraft in a program. A car company may produce millions of units. A launch company can feel triumphant about dozens of launches. That difference matters. Repetition drives costs down. Rarity keeps cost high. Space is still closer to shipbuilding than to smartphone manufacturing. In some corners, it is closer to cathedral building. Everyone wants the grandeur. Fewer people want the invoice. A rocket launch is not a guy with a wrench and a can-do spirit. It requires launch pads, ground support equipment, fueling systems, transport systems, clean rooms, test stands, tracking networks, mission control facilities. It requires launch pads, ground support equipment, fueling systems, transport systems, clean rooms, test stands, tracking networks, mission control facilities. You are not paying for the 5 minutes when the rocket looks photogenic. You are paying for the entire ecosystem that makes those 5 minutes possible. Think of it this way. If you go to a restaurant, you pay for the meal, but hidden inside that bill is rent, refrigeration, staffing, supply chains. Space works the same way, except the kitchen is on fire by design and the ingredients are cryogenic. Human spaceflight makes all of this worse. That is not a moral criticism of astronauts. It is a cost criticism of keeping them alive. Cargo is easy to please. Cargo will not panic. Cargo does not need oxygen. Cargo does not need water, food, or temperature control. Cargo does not need radiation shielding, waste management, pressure vessels, emergency systems, medical contingencies, or abort capabilities. Once humans are involved, every design decision gains a second shadow. Can a person survive this? Can a person operate this? Can a person escape this if something goes wrong? Human life is precious, and preserving it in space is expensive in the way a diamond vault is expensive, except the vault is also being shot out of a cannon. That is why sending people to space is drastically more difficult than sending hardware. It is also why many of the glorious promises people make about mass space tourism should be heard with a raised eyebrow. We may get there in time. I suspect we will. But the path is long because every shortcut in human spaceflight is written in invisible ink that turns red when somebody dies. There is another reason space travel is expensive, and it is less dramatic but equally important. The environment of space is hard to repair. On Earth, if a truck breaks down, you pull over. If an airplane has an issue, it lands. In orbit, there is no shoulder. There is no nearby mechanic named Earl. There is no kindly warehouse with replacement parts. If something fails, the mission may be crippled or lost. That means systems have to be designed to work the first time, and keep working. Redundancy gets added, margins get added, testing gets added, cost gets added. And because missions are long and unforgiving, components often need to be radiation hardened or qualified for conditions far nastier than Earth-bound electronics. The laptop on your desk lives a sheltered life. It enjoys climate control, gravity, and the occasional coffee spill. A spacecraft computer may have to endure vacuum, radiation, extreme thermal cycling, and years without human touch. You can buy consumer electronics cheaply because the consumer is allowed to suffer disappointment. In space, disappointment arrives at orbital velocity. People also underestimate how much of the expense comes from uncertainty. When industries are mature, people know what things cost. They know how long tasks take. They know where the bottlenecks are. In space, many projects remain frontier work. Frontier work is wonderful for speeches and terrible for budgets. You discover problems midstream. Suppliers slip. Components fail tests. Materials behave strangely. Software reveals fresh demonic tendencies. Then schedules move, which raises labor costs, facility costs, financing costs, and sometimes the blood pressure of everyone in the county. It is one thing to build a bridge with centuries of accumulated practice behind it. It is another to build a spacecraft system where some part of the architecture is still half experiment, half doctrine, and half prayer. Yes, that was 3 halves. Space accounting has strange geometry. There is also the insurance problem. When payloads are massively expensive, launches become wrapped in financial caution. Insurers care about reliability history. If a system lacks heritage, or if it has had failures, the cost of using it rises in ways that are not always visible on the brochure. People are not paying for a ride. They are paying to reduce the chance that the ride becomes a smoking anecdote. And this brings us to a point that irritates many romantics. Space is expensive because the customer base is still relatively narrow. Most people do not need to go to orbit. Most economic activity still happens comfortably under the sky God gave us. Space services matter enormously, of course. Satellites handle communications, navigation, weather, intelligence, and remote sensing. But actual transport to space remains a niche service compared to roads, aviation, shipping, or even data centers. A niche market with hard physics is not a recipe for bargain pricing. It is a recipe for high margins, heavy risk, and people on podcasts announcing that disruption is imminent for the 17th year in a row. Now, to be fair, costs have come down in some areas. Reusability has changed the picture. Better manufacturing methods have changed the picture. Small satellite markets have changed the picture. Space today is cheaper than space used to be in many meaningful ways. Space today is cheaper than space used to be in many meaningful ways. But cheaper does not mean cheap. That distinction matters. That distinction matters. A private jet may be cheaper to operate than a Saturn V, and yet it remains well outside the budget of a man whose chief asset is optimism. In the same way, reusable rockets can lower launch costs without turning orbit into a bus stop. Reusable rockets can lower launch costs without turning orbit into a bus stop. You can shave off huge percentages and still be dealing with enormous absolute numbers. Space has a way of humbling adjectives. Some people hear that rockets are reusable and assume this solves everything. It helps. It helps a great deal. But reusability is not magic. A reused rocket still has to be recovered, inspected, refurbished, refueled, integrated with a payload, and launched, within a system staffed by highly trained people. An airplane lands and flies again, because aviation spent generations building a mature operating culture around that model. Space companies are building that culture now, under harder physical conditions and far lower traffic volume. It is a real achievement. It is also not a coupon code. And then there is destination. Low Earth orbit is one thing. The moon is another. Mars is another. Deep space is another. Every step outward drives up complexity. Longer durations, more life support, more radiation exposure, more communications delay, more propulsion needs, more autonomy, more failure modes, more mass, more cost. People talk about Mars with the tone used for discussing a new suburban development. Mars is not a suburb. Mars is a red warning label with scenery. The farther you go, the less Earth can help you. That alone should sober the room. So when people ask why space travel is expensive, the answer is not one thing. It is a stack of things. Gravity is expensive. Fuel is expensive. Reliability is expensive. Low production volume is expensive. Specialized labor is expensive. Testing is expensive. Safety is expensive. Infrastructure is expensive. Human survival is expensive. Uncertainty is expensive. Distance is expensive. Delay is expensive. Failure is ruinous. Success requires precision. Precision costs money. And beneath all of it lies a more ancient truth. Space travel is expensive because human beings are trying to do something magnificent. That may sound lofty, but it is also practical. The grandest achievements are rarely cheap at first. Cathedrals were expensive. Railroads were expensive. Air travel was expensive. In every case, there was a period when only states, great firms, or unusually determined people could afford to push the frontier outward. Then, knowledge accumulated, supply chains matured, standards emerged, operations improved, costs fell, access widened. Costs fell, access widened. The thing became ordinary, which is humanity's most underappreciated form of victory. We turn miracles into infrastructure, and then complain about the ticket price. The thing became ordinary, which is humanity's most underappreciated form of victory. We turn miracles into infrastructure, and then complain about the ticket price. Space is still in the expensive phase because we are still wrestling it into regularity. That does not mean the dream is false. It means the dream is early. One day, the cost curves may bend farther. Launch may become routine enough that today's prices seem antique. Orbital industry may grow. In-space refueling may mature. Nuclear propulsion may change the arithmetic. Manufacturing in orbit may reduce burdens. Costs may push the frontier toward normal commerce. That would already be a civilizational triumph. Until then, the high price of space travel is the bill for fighting nature at its hardest edge. And nature, like an old landlord with a bad temper, always wants her rent.